Okay, this is going to get a little bit challenging. Now, in this assignment, it's going to seem like I'm overcomplicating things. It's for the long-term benefit. Because if we do this just the easy way, then we get to the hard stuff, you're in trouble. Okay, so I'm trying to set up for the future here in this unit. Okay, you're going to need this, the radical sheet. You're going to need to add another radical. You're going to put square root of 256 equals 16. Okay. Now, you're also going to have this little sheet I made up. Okay. You are going to simplify now with rational exponents. Now, here's what we do. Here's how I put equals, and these are both fourth roots. So make one parentheses. You can do this in multiplication. And outside you put a rational exponent of a 1/4 power. Not a fourth power, a 1/4 power. Not a fourth, a 1/4. Then to find the inside, you multiply the insides of your radicals. You take 8 times 32. That's 256. Now, here's what you're going to do. You're going to make 6 lines like you would on properties of exponents, but you'll need 2 rows. First thing, you write your base down. The only base you got is a 256. Remember, we're not looking here. We put a 1. 1 times 1/4 is 1/4. Okay? If you have a negative exponent, it has to switch positions, but there are not any negative exponents today. There'll be some negative base, big base numbers, but the exponent will not be negative. And you can cross out this to rationalize a denominator is for something later. I'll explain it when we get to it. Now, this line here, you're going to circle your exponents, the only one you got. Now bring it over. Now, after you brought that over, if the exponent is a rational exponent, meaning it has a bottom, go look at your 4s on your sheet, your fourth roots, and see if 256 is there. Okay? So, my 256 is there, it's 4. So slash that out and put 4. Okay? That is no longer a rational exponent, it's a whole exponent, 4 to the first power. Okay? 4 to the power of 1. 4 to the power of 1. So now I come down here. That is now a whole exponent, not a fraction. So you just write it and then you simplify. 4 to the first is 4. Okay, next problem. That and that you won't have to do today. So it's really just 4 things to think about. Now, you make a 1/3 power because the radicals are cubed roots. So now you take 9 times negative 24. That's negative 216. So the base, negative 216, put it in parentheses, is 1/3. Now, some people are going to say, why'd you cross that out? You got a negative. Yeah, the exponent ain't negative. The base is. You don't switch a base if it's negative. Okay, the base don't matter. It's all the exponent. Okay, so that's the only exponent we got. It's a fraction. It's a rational exponent. You bring it over here. Now, since it has a denominator, you circle it. Look at your cubed roots, the 3s. Look at the right list, too. That drives me nuts when people don't look at the right list. I'm looking at 3s. And 216 is there. It equals 6, but since it was negative 216, it would be negative 6. Remember, you can take the cube root of negative numbers. You can take odd roots of negative numbers all day. They just end up being the negative factor. Evens can't have the negative. That's when the I comes in. That's not going to come up. Okay, now it's a whole exponent. Okay, whole exponent. So I put negative 6 to the 1. That's negative 6. Do not go work on this assignment, okay? You saw me do those two and you think you got it all figured out, yet you don't, okay? So radical 3 times radical, they don't have degrees, so they're automatically 2's. They're square roots. So when we make our parentheses, we put it to the 1/2 power. Then we take 3 times 4, that's 12. Okay, I don't know why I'm using a calculator. That's idiotic, okay? on my part. If somebody needed a calculator to do 3 times 4, I wouldn't. I'm not calling you idiotic. It's me. I'm a teacher. I should not do that. Okay. So 12. 1 times 1/2 is 1/2. Okay. All right. So that's your power. So we go 12 to the half. Now go look at your 2's. Is 12 just a pair? Is it a perfect square? No, it's not. So you don't do the just slash it out and say it's to the first power. Here's how you now go down here. If you weren't able to get rid of the bottom and it's still a rational exponent, here's what you do instead. You put a radical and make it a 2, and you'll get rid of it that way. Now inside the radical, you're going to put 12 to the first, which is just 12. Now to simplify, since that's in the radical, you bring it down here, okay? If you have a base number inside of the radical, you make it into 2 radicals, okay? Both of 2's. Now go to your 2's and see what 12's divisible by. Is it divisible by 9? No. Is it divisible by 4? Yes. So I put the factors 4 and 3 in the radicals, and the first one goes bye-bye and replaced with its whole of 2. So you put a 2 and a radical 2 over 3. So if you are not able to do the slash out, you go down here and make a radical of a degree 2, and then you can just put 12 to the first, but you got to simplify the inside. Okay, next one be the 1/3 power. So now I take -7 times 49, -343. Okay, so you put your base, put it in parentheses if it's a negative, and it's just 1/3. Now that's my only exponent. It has a bottom, so bring it over here. Now see if you can just get rid of it there by looking at your cubed root list, the 3's, and 343 is there at 7, okay? So now the 3's gone and it's 7 to the -7, because it was a -343. Try to remember that. If you're taking the odd root of a negative, you can do that. It'd just be the negative. So now the base does not have a rational exponent. There's no bottom to it. It's just -7 to the first. So I don't need to make the radical because I got rid of my bottom that way. Okay? So no radical. Radical's gone. So -7 to the first is -7. Now if you'd like to pause your video and go do 1 through 4, you may. Remember, these have 2's. Okay? And do 1 through 4. You're not going to know how to do 5, so you'll have to resume the video. Now, we're simplifying. Now there's going to be variables involved. There's going to be more than one base. Remember, the radicals of a 2. So we put equals and make 1 parentheses to the 1/2 power. And then 50 times x to the 5th. You're still going to get rid of these. You won't have to use them. So now I write 50 times x, but I got to figure out the powers. It's 1. 1 times 1/2 is 1/2. Now 5 times 1/2. It's going to be 2.5. You're going to write 2.5. Okay? Now here's why it's 2.5. 5 times 1/2. I could put a 1 under the 5 and it'd be 5 over 2. Then that's improper. 2 goes into 5 twice, 1 left over. Okay, 2.5. Now circle all your powers. Remember, these are 2 separate powers. That's 2 bases of x, 1 to the 2nd, 1 to the 1/2. Now when you're lining them up over here, you're going to put your whole one first, the 2. So x to the 2nd. Now you put in your rationals, the ones with fractions. You're going to put the 50 first with its 1/2 power. Then you put your x with its 1/2 power. Now this has no bottom, it's a whole exponent, so I go to the next one. This has a bottom of 2. Now go look at your list and see if 50's in the 2 row. No, it's not, so you can't slash it out. Now this also has a bottom, but since it's a variable, I'm obviously not going to have it on the list. So we have to go down here. Now the one with a hole, you just drop that down. Now look at your ones with bottoms. What do they have on the bottom? They have a common bottom, a 2. So if they have a common bottom, common denominator you could call it, you make one radical of a 2 degree. And inside, now those 2's are gone, and inside you put 50 to the first, which is 50. Then x to the first, which you could just write as x. If you want to put the first, fine. Now here's how the simplifying works. X to the second, the outside can't be simplified. Okay. Then I make a radical of a 2. The x cannot be simplified, but the 50 can. How you simplify that, you write that down here, just the 50. You just make your radical, put any variables in there, those aren't coming out, okay? And you see what that can divide by from your square roots, because it's a 2. So 50, divide by 49, nope. Divide by 36, nope. Divide by 25 is 2, 25 and 2. Cross that out, 25 is 5. So, here's how you align this. You put your 5 factor in front of the whole expression, and the 2 factor goes inside the radical, and you're done. You follow those steps, you shouldn't go wrong. Now it's a 3, so I raise it, so the expression's to the 1/3 power. So I've got 32 times a to the 5th. So the bases, I have a 32 and an a. Now we figure out what the powers are. Put a 1. 1 times 1/3 is 1/3. Then a, 5 times 1/3. It's 5 over 3, which is 1 2/3. You do put 1 2/3. Remember, those are 2 separate powers. You've got to get that down. It's not just 1. It's a to the first times an a to the 2/3. Now you line up the 1 without a denominator first. That's a whole exponent. Then you line up the ones that got fractions, the number first preferably. The base number first, then followed by the variable, the a to the 2/3. Okay, now that does not have a bottom. This does, and this does. Go look at your 3's and see if 32's there. It's not. Go look at your A's not going to be there. You know that. So we cannot slash anything out. Okay. Now I go down here. 1 doesn't have a bottom, so I just drop that down. That's a whole. Okay. Now the ones that do have bottoms have a common bottom of 3, so I make one single cube root. And then that allows me to eliminate the 3's. That way. So 32 to the first is 32. A to the second is a to the second. Now simplify. A to the first you can just write as a if you want. If you want to keep the first there, that's fine. Now make your radical. The variable you keep in there. But the big base number you take over here and see if you can simplify it. That means write it as a product of 2 cubed roots. Now you're looking at the 3's, okay? So 32 is 8 or nothing. By the way, if it doesn't divide by 8, you're just going to keep the 32 in there, okay? Well, it works. So I put the factor of 8 and 4 because the cube root of 8 is 2. Remember, the reason why it's 2 is because 2 times 2 times 2 is 8. Now I put the whole factor here of 2 and then 4 inside. Okay, next problem. Cube root of 54y to the 10th x to the 5th. So write that as a 1/3 power. Then 54 times y to the 10th times x to the 5th. So 54 times y times x. 1 times 1/3 is 1/3, so that's a fraction exponent. Then 10 times 2/3. 10 times 1/3, excuse me. That's 3 and 1/3. Remember, that's two different exponents, so I make circle, circle. Then 5 times 1/3. You probably want to circle them right there so you can see clearly. 1 and 2/3. So which one of those exponents? I mean, there's 5 of them. The 3 and the 1 are not fractions, so put those first. Y to the third. Once you write it, cross it off. Then x to the first. Once you write it, cross it off. Now write all of your fractions, the 54 first. Then the y to the 1/3 on the y to the 1/3. Then 2/3 on the x. Now circle all the ones with bottoms, see if you can slash those out on the spot. So go look at your cubed root. 54 is not here. Neither is y, neither is x. Okay, the variables are not, so you can't slash them that way. Okay. So I drop the ones with holes just in the front. Y to the third times x to the first. Then look at all your fractions. 3, 3, 3. So I guess I can make one cubed root, and that allows me to get rid of the 3's. But then the 54 to the first goes inside. It's just 54. Y to the first inside, you can just write y, or you can put a 1 on the y. But try not to put a 1 with the 54. We know that's 54. Then x to the second. Now what can I simplify? Well, y to the third, no. X to the first, well, you could write it as x if you wanted to. Then when you get to the radical, you keep the variables inside. Leave yourself some space, please. Okay? Now we take the cubed root of 54 and see if we can simplify it. Write it as a product of two cubed roots. So you're on the cubed root. So 54, it would start at 27. 27 and 2. So you replace that with 3. Now, how do we organize this? Now the 3, the one that the radical got out of, and then the 2. Bam. Okay. Okay, next one. 1/4 power. And then you have 625 times x to the third times y to the 18th. So we got 625 times x times y. So 625 is going to be to the 1/4. 3 times 1/4 is 3/4. Now 18 times 1/4 is 4.5, because it's 4 and 2/4, but it simplifies to 4.5. And when I write the 4.5, remember that's two different ones. So find your whole exponent, the one without a fraction, you write that first. Now write all your fractions starting with the 625. To the 1/4, x to the 3/4, y to the 1/2. Now circle all those bottoms, all the ones with bottoms. Look at your 4, see if 625 is there. Oh yeah, booyah, it's 5. So that one goes away, and we have 5 to the first. Okay. These ones are letters that cannot be done. Now when you're dropping the ones with whole, remember that one's now a whole, 5 to the first. Put the one with the base number first, please. 5 to the first, try to remember that. And then the y to the fourth. That's how it's supposed to be written. Then now we don't have the same bottom, so what we do is we make two separate radicals. One with a 4 and one with a 2. Okay? So cross out the 4 and the 2. So in the 4 you put x to the third, and in the 2 you put y to the first. Okay? Now simplify. 5 to the first is 5. Y to the fourth can't be simplified. Now I run into my radical of 4. Now there's no number base in the radical. It's just x to the third. So I don't even have to think about simplifying that. Then in the other radical you got a 2. Y to the first, I mean you can write y, but that's about all you can do with that. Okay. Remember, so if there are two different bottoms, you just make two radicals. Simple as that. Okay, that's good enough. If you want to go do 5, 6, 7, 8, you can. Okay, number 8, you'll have to make two radicals because there'll be different numbers on the bottom. Because you're going to have a 3/4 and a 1 1/2. Okay, so one will be a 4, one will be a 2.